In this video, I'm going to give a brief introduction to vectors and talk about various properties about them, and also how we can add and subtract vectors with each other. I think when learning about vectors, it's easiest to start by visualizing on a graph. So here I've got an XY coordinate system with an x-axis and a y-axis, and we can define 2 points, any 2 points on the graph. So we can start with, say, 0, 0, the origin, and go to some point like this, say 3, 2. We can call them P1 and P2 just to make it easy. And so this is our starting point, and this is our ending point. So to draw a vector, we simply draw an arrow connecting the two. And that's how we denote vectors, is by arrows. How we would write out a vector in terms of a variable is we denote it by, say we call it P, and we put an arrow above it. Or sometimes you'll see half arrows like this. Um, so that indicates to us that we're dealing with a vector. Now in textbooks and stuff, you might see vector quantities just given as bolded letters, um, which is hard to do. It's hard to bold letters when writing it out. So arrows is the easiest if you're working on paper. So I'll give a few properties of vectors when you're drawing them out. One is parallel vectors. So when are vectors parallel? Vectors are parallel when they face in the same direction. So if you have a vector like this and like another vector like this, they're considered parallel. Now notice that they aren't the same size. They don't have to be the same size to be parallel. They just have to face in the same direction. So when are vectors equal or equivalent? Well, they're equivalent when they're parallel and when they're the same size. So, these might not be drawn the same size, but assume they are the same size. So they're the same length, they face in the same directions, so we say that they're equal. Now, notice one thing as well is, in order to be equal, they don't have to be in the same spot on the graph. You could have a vector like this here, and then you could have one down here. They both have a length of 2, and they both point along the x-axis. But even though they're in different locations, they're still considered equal. Now, another thing is antiparallel, if I can spell it properly. Antiparallel, or opposite. This is where you have a vector that they face in the opposite direction. So 180-degree difference in the way they face. That is antiparallel. So another notational note here with vectors, just something that when you see it, you'll know what it means. If you have a vector P, a lot of times the magnitude of this vector, so the length, is denoted like this. They put these just vertical lines around the P, so you know that this is referring only to the magnitude of the vector and not the direction component. Sometimes you'll also see it just written as P. This is a bit more confusing, but like again in a textbook, you'll see if you see a bolded, let me try to draw a bolded P, and they refer to P, not bolded, that would be magnitude. But I prefer to, have my arrow and then magnitude with the vertical I don't know if you call those brackets or whatever, vertical lines around it. So one final thing to talk about is if you have more than one vector, how do you combine them? How do you add them together? So let's say you have a vector like this, and say from the same spot like this. How would you add these together? The way we do it is a way to easily visualize it is, so we'll call this vector capital A and capital B, and we want to find this, A plus B equals, let's call it C. An easy way to do this is whenever you have vectors, more than one of them, you can connect them tail to tip. So if we pretend this isn't here and we move it up here, then we have A, which connects to the tail of B, and then B, which goes down to this point here. Then what we do is the sum of these is kind of similar to displacement, where we take the shortest distance between 2 points of distance. We connect the tail of the first vector to the tip of the second vector, and that gives us a resultant vector C. So we'll get into the math of that, how we do that mathematically, in the next few videos. But that is just a visual representation of what it looks like to add vectors. What if we want to subtract two vectors? Well, this is similar. What we do is we note that negative vectors is the same as the antiparallel version of the vector. So saying A minus B is the same as saying A plus the antiparallel vector of B. So if you draw this out, say you have two vectors, A, and you have another vector, B. A minus B would be A plus the antiparallel of B, which, if I draw it out again over here, is just the 180-degree flipped version of B. Then, doing the same as up here, you can connect the tail of the first vector to the tip of the second vector. So that is a brief introduction to vectors and a visual representation of vector addition and subtraction. And a lot of these notational things will be more clear as we get into the actual mathematical calculations of vectors, but hopefully this is useful just to visualize how vectors work.